Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are continuing with our organic chemistry series, and we'll be looking at the chemical properties of organic compounds. And if you look at the chemical properties of organic compounds, we see there are many different types of reactions that organic compounds can undergo. One of the types of reactions that organic compounds can undergo are combustion reactions. The combustion reactions are reactions where the organic compound reacts with oxygen. And we see that in all cases when organic compounds, no matter what they are, they react with oxygen, we see that carbon dioxide, water, and heat are the products. Now, a simple example is that of a lighter. If you look at a lighter, we have butane fluid in there, C4H10, and when you spark it, it reacts with the oxygen in the air to form heat, which you see as the fire, the flame, and it gives off carbon dioxide and water as byproducts. Another example of a combustion reaction is the reactions of petrol in our car, where it gives off lots of energy. That's why it is used as a fuel, because it gives energy for the movement of the car, etc. Another type of reaction we have is addition reactions. We have elimination reactions and substitution reactions. In today's lesson, we will focus more on addition reactions. Now, if you take this example that we have here, if you look at these three examples that we have, and there are two more below, we'll see that in an addition reaction, we always see that alkenes undergo addition reactions. In this particular reaction, we see that the alkene is reacting with hydrogen, and then a double bond opens up, and then it forms the double bond. Basically, this goes away, and then we end up with two lines here, two bonds here, and then hydrogens are added here and here, and we get the ethane that is formed. So in this case, we see that this is an addition reaction, and in this case, we see that hydrogen is added. That's why this particular reaction is called hydrogenation. Because hydrogen is added to the reaction, it is called hydrogenation. Because it's the addition of hydrogen. If you look at the next example we see in the next example, again we have our alkene and HBr is added, and in this case we see that it again opens up, the hydrogen goes to the one carbon and the bromine is added to the other carbon, and this is called hydrogen is added and halogen is added. Hydrohalogenation. So this reaction is called a hydrohalogenation reaction because of the addition of hydrogen as well as a halogen. If you look at the next example, we see that in this case we're adding water, and if you look at the H2O molecule, you can separate it into H and OH. So the H is added and the OH is added, and this is also the reaction that can be used to say the formation of an alcohol, because we see that OH is added to the reaction, so this becomes ethanol by the addition of hydrogen and OH, basically the addition of water. And if you add water, then if you are, for example, if you are thirsty and you add water, then you become hydrated. So this is called a hydration reaction because you are adding water to the reaction. And it's the hydration is also in this case the formation of an alcohol. If you look at the next example that we have, we see that we've got our ethene molecule, and we're adding bromine and another bromine. And in this case, we see that the bromine goes, one bromine molecule goes to the one carbon and another bromine molecule goes to the other carbon. And this reaction here, we see that we are adding a halogen. So this is a halogenation reaction. So we get four types of reactions basically. We get a hydrogenation where we add hydrogen. So that's hydrogenation. When we add hydrogen and a halogen, we got hydrohalogenation. When we add water, we call it hydration. And when we add a halogen, then it's called halogenation. So we get four types of addition reactions here. And for interest's sake, I've even just put in this bottom one here. If you look carefully, this is exactly the same. Those two reactions are exactly the same. The only difference is the way we have written it. I didn't mention this before. Here we have a structural formula, and if you write it like this, CH2, double bond CH2, it's exactly the same, but this is called the condensed way of writing it. This is the condensed organic formula, condensed structural formula of this compound. And if you look at this example here again, we have CH2, double bond CH2, and you're adding chlorine to it. And then we see that the one chlorine goes to the one carbon and the other chlorine goes to the other carbon, and we get CH2Cl. Instead of Br we got Cl here, instead of Br we got Cl here. So this is also a halogenation reaction. So these two are exactly the same. The only reason I put it here is to show you that this is the condensed structural way in which you write this reaction. And if you see this reaction in the exam, then if you find it confusing, rather spread it out, write it as the structural formula as the one above here, and you will be able to see it much more clearly. Now, one more aspect in this types of addition reaction is the Markovnikov's rule. And Markovnikov's rule says that when the hydrogen atom that is from reacting with the organic compound will bond with the carbon atom which has the most hydrogen atoms. Now, if you look at this reactant here, we got 3 carbons, so it's propene, and then we're adding water to it in the presence of sulfuric acid in terms of your reaction condition. Now, if the carbon has to open up, we see that there'll be a space here, and let me just put it here for argument's sake. We'll have a space there because when this double bond opens, there'll be space for 2 particles to bond. Now the question is, in this case here, you got H and OH. Where will the OH go and where will the H go? Now, the rule is the hydrogen will go to the carbon that has the most hydrogen atoms. So if you look at the last carbon, actually not the last carbon, the first carbon, because we must start naming from here, it's got 2 hydrogens already attached to it. And this carbon only has 1 hydrogen attached to it. So the hydrogen that comes from the H2O will go to the atom, the carbon atom that has the most hydrogens, which is the last one. So if you look at this case here, we see that the last carbon accepted this hydrogen atom. And the OH that's left will go to the carbon with the least hydrogen substitution, which is in this case, the middle one. So that's why the OH goes here. So this is Markovnikov's rule, and Markovnikov's rule, just to reiterate again, that the hydrogen atom will bond with the carbon which has the most hydrogen atoms. So usually the hydrogen goes to the end and the OH will go to the center. If we had HBr here, for example, then the H will go to the end and the Br will go to the center. So Markovnikov's rule is very important in terms of addition reactions. So today that will be all we have. We discussed our types of addition reactions: hydrogenation, hydrohalogenation, hydration, and halogenation. They are all addition reactions, and all alkenes can undergo addition reactions. And we mustn't forget Markovnikov's rule as well, which shows that the hydrogen will bond with the carbon with the most hydrogen atoms. And also combustion reactions, we must not forget. The combustion reactions takes place when any organic compound reacts with oxygen to form carbon dioxide, water, and heat. And that will be the end of today's lesson. Thank you very much for listening.